It's that time again, time to learn more history. This time we will be learning about the scientific revolution. I hope you have a writing utensil that's a different color than what you did your notes in, and you should fill in missing information, extra information, and correct any inaccuracies that you might have in your notes. So the key thing to start off with understanding is that the Renaissance and Reformation, which are in the first bullet, ended up influencing the scientific revolution. Okay, so lots of changes happened during those two events in the Renaissance and Reformation. Now you have new ideas about science or the physical world. So the key thing to understand is that until the 1500s, Ptolemy and Aristotle were the main sources of scientific information. So that starts to change, and the old belief was that the Earth was the center of the universe, which is the geocentric theory. Geo comes from the Greek word for earth, and this idea seemed to make sense, and the Catholic Church believed in it. So that's what the common belief was until the early 1500s. It was questioned in the 1500s and 1600s. So the first person on the chart is Nicholas Copernicus, who came up in the Renaissance unit, and he is the originator of the heliocentric theory. And heliocentric comes from the Greek word for sun. His idea was that the sun was at the center of the universe, and the Earth and other planets revolve around the sun. When you are happy with your information on page 1, go to page 2, and I will remind you that if the video is going too fast or you need to write something in, you should pause the video so that you can do that, and then restart it when you're ready. Okay, page 2. So the issue with Copernicus was that some people did not agree with what he had to say. They were sticking with the old beliefs. But the key thing is that people worried if Ptolemy was wrong about the planets, all human knowledge could be questioned. Like everything we know could be questioned. So they were seeing this as a really big deal, Copernicus's new idea. So there were people that began to support what Copernicus said and prove he was right. Tycho Brahe from the Netherlands found evidence that supported Copernicus's theory. Kepler also did, and he supported heliocentric view. He figured out the orbits of the planets was elliptical, which is an oval. So make sure you have that word correct, ellipse or oval. That's the shape of the planets. And these scientists are proving that Copernicus is right. We also have Galileo. So Galileo had made a telescope. He took it even further than Copernicus. He observed Jupiter's 4 moons with his telescope moving around Jupiter, just like Copernicus said the Earth moved around the sun. So this did not sit well with the church. They did not totally agree with this conclusion. So here are the problems he faced. First up, they criticized his ideas because they contradicted what they had always thought for hundreds and hundreds of years. The Catholic Church was against him because the Catholic Church did not think that the heavens moved. They were fixed, according to the Catholic Church, and perfect. So that belief of Galileo's didn't go well with the church. So then what happened is Galileo was brought before the Inquisition, put under house arrest for the rest of his life, and they threatened to kill him unless he stated publicly that the earth was motionless and at the center of the universe. Even though he muttered something under his breath to kind of undercut what he had said, publicly he needed to say this. So you can see how powerful the church still was. They caused him to be under house arrest for the rest of his life. Okay, at the bottom of this page, I want you to write your middle name. And then after you've done that, go to page 3. So the top of this page talks about the scientific method, which was in the PowerPoint if you've already watched that. So again, they're mentioning observation, experimentation, and here's the influence of the Renaissance. Because of the Renaissance, the works of Plato, who was a Greek philosopher, were rediscovered, and he thought that people shouldn't just accept how things appeared, that they should look beyond that. and he thought math would help with that. Anyway, so some guys that also were into the scientific method, we have Bacon and Descartes, and they did not think the physical world had to fit in with the Catholic Church's teachings, which was also mentioned in the PowerPoint. We have Bacon. He stresses experimentation and observation. Obviously, that was an important part of the scientific method. He thought science should improve people's lives with practical technologies. Then we have Descartes. Human reasoning is the best way to understand. Reasoning is like the ability to think logically about something. So humans should think logically about something, and then they would understand. So this last little part, we have the scientific method, a definition. I probably got it from the glossary, but a lot of people wrote really short definitions or stopped after step-by-step process. So the glossary was just better for this definition. Anyway, scientific method, and then why step 4 might be important would be your opinion. Experimenting to test the hypothesis. Why would you want to repeat that more than once? If you're not sure, ask Miss Finnerty. Okay, you can move on to the last page. We're almost done with our science. So these are breakthroughs in medicine and chemistry. Ooh, don't get too excited. So we have Vesalius, who wrote a book looking at the human body, and he got invited to autopsies, and sometimes he autopsy bodies himself so he could learn more about the body and be accurate. Then we have Ambroise Paré from France. I've underlined his key contributions. Ointment to prevent infection, kind of like Neosporin, but it wasn't specifically called Neosporin. So, new surgical techniques, artificial limbs. William Harvey dealt with circulation of the blood in the heart. Antony van Leeuwenhoek from the Netherlands perfected the microscope, first human to see cells and microorganisms. So if you wanted to be the first to do that, too late. All right. Lastly, we have Newton, Isaac Newton. So he was pretty young when he had the idea about gravity. So make sure you have that written down somewhere. Something about gravity. And that was Isaac Newton's idea. He thought gravity kept the planets in their orbits. He had a book about gravity. He did think that there was motion in the universe, and he also thought it could be measured and described mathematically. So this went against what the church said. His ideas were influential for a long time, up to the early 1900s, and calculus. He helped create calculus, the type of math that you might do when you're a senior in high school and you took algebra 8th grade, then you have room for an extra math. That might be a math that you would take. Anyway, so you can thank Isaac Newton for that chance. Before you put down your pencil, at the bottom of this page, I want you to write your favorite candy. So if you missed anything in the video and you need to go back, now would be a great time to do that. Otherwise, keep studying history, stay historic, and stay in school.